Okay, class, this is problem number 3 from section 3.8. I think in this case we need to look at all the parts, but kind of look at them one at a time. So in part A, we're just asked to write an equation for just this diagonal line on the top. That's the top of the brick curb. So they give us a little bit of information that I think is rather important. Right in this little part of the description, they tell us that the brick curb starts at 0.75 feet above the ground, so that's this coordinate point is 0, 0.75, and slopes up to 3.25 feet above the ground, 44 feet away. So this second point is the 44, 3.25 that we see here. The slope of that line, or the slope of that line segment, would be 5/88. And since we have the y-intercept at, this would be 3/4, same as 0.75, I know that the equation of that line is 5/88 times x plus 3/4. So we've got an equation for f of x then. That's the height of the, from the ground to the top of the brick curb. And we can move on to part B, and in this case we're trying to build an equation for g of x, the height of the ground to the top of the concrete walkway. So that's this kind of curvy line that we have here. And that's going to be kind of hard to do, come up with that equation. So what we really need to do, I'm sorry about changing the page there, but what we really need to do is pay attention to like all of these vertical differences. All of those, see how they're getting bigger, and then smaller, and then they get bigger, and then they get smaller again. Well, this is all in a periodic fashion. So that distance between the brick curb and the top of the concrete walkway, that happens in kind of a periodic fashion. So I wrote a little paragraph here describing that. I'm going to use an adjusted cosine function to model that distance. So a couple of things of note here. In the second part of our description, they tell us something about the concrete walkway. They say in every 8 feet, so I think the period is 8 feet, the concrete walkway varies from 0.75 feet below the curb, so that's this distance is 0.75 feet, to 0.25 feet below the curve. That's this little distance right here. And then it goes back to 0.75 feet below the curb, and then 0.25 feet below the curve, and then 0.75, and so on and so forth. So a couple of things of note here. I note that looking at, let me see if I can highlight this, these two values, those are going to be our two maximum distances between the brick curb and the concrete walkway. And I know that both of those are going to be 0.75 feet of distance. That's the two bigger horizontal vertical lines there. And then halfway between that, we wind up with the distance between the brick curb and the concrete walkway of 0.25 feet. Since the period is 8, really I should write that in, 8, I know that this is going to be our coefficient, if I can spell, inside the cosine function. So cosine of, we're going to have a pi over 4 times x. Kind of went off the page there. So apologize for that. Keep in mind here that basically we can use all of this information to write a function. So I know that the maximum distance between the brick curb and the concrete walkway is 0.75 feet. Minimum distance is 0.25 feet. So the middle distance between the brick curb and the concrete walkway is half a foot. That means the amplitude would be the difference between the maximum and that middle distance. So that's 0.25 feet. There's no horizontal shift because this distance between the concrete walkway and the brick curb starts out at a maximum, just like a typical cosine function. So here, if we have the period as 0. And I wrote period there. Let's cross that off so we don't get confused. The variable coefficient, let's call it. That's pi over 4. And then the amplitude is 0.25. We have a vertical shift of half of a unit. And then the horizontal shift is 0 units. So I'll say that this distance between the brick curb and the concrete walkway, if that's h of x, 0.5, see the vertical shift right there. And then we'd have a amplitude of 0.25, be the coefficient of the cosine function. And then the variable coefficient right here, this provides a horizontal stretch of pi over 4 units. And then we have finally the horizontal shift of 0 units. So what I need to do then to get g of x is use that f of x function we had from before and subtract this distance between the brick curb and the concrete walkway. And then that will give us this vertical distance between the what do we call it? The ramp, basically top of the ramp, and then the ground. So this is growing, and it's in kind of a slanted sinusoidal pattern. It's getting bigger than smaller, but over time it's growing, or over that horizontal distance. So you can see here we've got the function, and we just need to do something with this g of x function. Almost done here. Now we're going to take that g of x function, and I rewrote it slightly. So notice I just did minus 1/2, and then minus this cosine function. I just rewrote the 0.25 as 1/4, and kind of cleaned this up over here. So g prime of x then, just looking at the separate parts, the derivative of 3/4 is 0, the derivative of negative 1/2 is 0, derivative of 5 over 88x is 5/88, and then the derivative of this 1/4 cosine of the quantity pi over 4x, we have to use a chain rule there, but it would be 1/4 times negative sine of this inside stuff multiplied by the derivative of that inside stuff. Okay, and then if I try and answer these questions they had down here about the slope of the ramp at those 2 points, you're just finding g prime of 9 and g prime of 15. So at 9, when x is 9, the ramp is sloping up, and at when x is 15, the ramp is sloping down slightly. And we might think of these units as feet divided by feet, which really is nothing, but that's not right. The units are feet from the beginning of the ramp to feet above the ground per feet from the beginning of the ramp. It's a y over x sort of a thing. So then looking at the last part, the child walking up the ramp, the steepest and up and the steepest down slopes, we're just looking at a g prime of x function, and then we want to know when this g prime of x function is biggest or smallest. And we could graph this, I'm sure, and then look for minimums and maximums, but this is actually pretty easy to look at. This trigonometric part over here, this periodic part, it varies between -1 and +1. So that means that pi over 16 multiplied by at least -1 and at most +1 is either negative pi over 16 or positive pi over 16. So we just need to take 5 over 88 and add or subtract that quantity. So that g prime of x is always between these two values. That's why we get our steepest downslope of negative 0.1395 and our steepest upslope of 0.2531. So I hope that helps. We'll talk about this more in class tomorrow, I think. Have a good day.